Okay, so far we've learned two ways to solve quadratic equations, right? We learned to do it by the quadratic formula, which you guys did that in physics also, and we've also learned to just put the quadratic into the graphing calculator and look where it crossed the x-axis, right? That's the two ways we've learned. The last way that you can solve a quadratic is by factoring, okay? So when you're solving a quadratic equation by factoring, when you factor, it's going to look like this. It's going to have two parentheses here, and you're going to split the x squared into x times x. So there'll be an x in the front of each parentheses. Okay? Now, there'll also be a plus or a minus and a plus or a minus, and we've got to figure that out yet, and I'll show you how to do that. So the way you factor, and you should have this table on your notes page, is you do factors of the C number. So what is C in our equation?
10.
Yeah, C is 10. So we're going to do factors of 10. That means factors mean the multiplication problems that equal 10. So think of multiplication problems that equal 10.
5 times 2.
5 times 2 and multiplication problems.
2 times 1 times
2 times 5. So we don't have to reverse it, but what else?
10.
What? 1 times 10. Okay, those are the only two multiplication problems that equal 10. Now, those same numbers have to add to be the B term. So what is our B term here? 7. So what's 5 plus 2? 7. What's 1 plus 10? 11. So the ones that are going to work are the 5 and 2. Because the 5 and 2, when I multiply them, they equal the C term, and when I add them, they equal the B term. So the way this would look is, since both of those are positive, both of these signs are going to be pluses, and it's plus 5 and plus 2. And that's the answer. Okay. Not too bad. Now, I want to show you something, especially that will help with your final exam since it's multiple choice. There is a way, it's called double distributing. Some teachers like to call it FOIL. I don't like to call it FOIL because FOIL only works when you have 2 and 2. But if you distribute, it always works no matter if you have 2 and 3 or 2 and 4, it works all the time. So when you distribute, we're going to multiply the x times the x. What's x times x?
X squared.
X squared. Then we multiply the x times the 2, which is what?
7x.
No, x times 2.
10x.
2x.
Oh,
Then I've multiplied the x by both of those. Now I'm going to multiply the 5 by both of these. So what's 5 times x? 5x. And then what's 5 times 2? 10. And then in the middle, there are like terms. Those two are alike, so I can add those together.
7x.
So x squared plus 7x plus 10, which is what we started with up here.
So mainly you just find out what the factors of it is when you plug it in to see if it equals what the first
Right. So if it's a multiple choice test, I'm going to take my choices maybe and distribute those and see which choice equals what I started with. Does that make sense? So, but if you get really good at this might be faster, but I'm just showing you a different strategy you could use on a multiple choice test. All right? All right, so let's keep going with some more examples here. But the answer that you would put in Math Lab is this right here, all of this. You would put in parentheses x plus 5, close parentheses, another parentheses, x plus 2. That is the factored form of that quadratic. Okay? Okay? Now, probably the hardest thing on this is when the signs start changing. So, just a minute ago, everything was positive. This time we've got some negatives and positives. But you still do the same process. Okay, so I want factors of my C number, which are 9,
3 times
that the sum has to be,
10.
and be careful here, it's not a positive 10.
Negative 10.
Blake, you have to be in the workshop, which means you need to be personal, which you need to be on the computer. The sum has to be negative 10 this time. Close your computer. Okay?
So the sum
So-
is the number in front of X.
Right, the sum is the number in front of X. It's the B. Yeah. So the B and then the C is your factors. Okay? All right, so we know that 3 times 3 is 9. And we know that, what else? 1 times 9 is 9, right? But what's 3 plus 3? 6. And what's 1 plus 9? Okay, we got a little bit of a problem because that's a positive 10 and not a negative.
Well,
Anybody know how to fix that?
1 times negative 9 is
Negative 9.
negative 9.
So that's not going to work. But we can fiddle around with the signs to make it work. What would we do, Blake?
Negative 1 times negative 9.
Okay, so negative 1 times negative 9, is that still positive 9?
Yes.
Okay, now what's negative 1 plus negative 9?
Negative 10.
Negative 10, so that's going to make it work. Does everybody understand what he did? He just changed the signs. So my factors, again, X goes in the front both times. And the factors that worked were negative 1 and negative 9. So it would be minus 1 minus 9. And that's the answer. Okay?
Okay, so did you just like, was that really me? Because, how do you even say that?
So the only way to get a positive when I multiply,
Or is it
if I do 2 negatives or if I do 2 positives, right? So positive 1 times positive 9 was a positive 9, but when I added those, Donovan, it didn't equal negative 10. Donovan, you asked me a question and now you're not paying attention.
Oh, yeah.
When I did the positives, it didn't equal negative 10. So I knew these two had to be negative so that when I multiplied, it'd still be positive, but when I added, it would be negative. Okay? All right. Okay, so let's go on to this one. So what do my factors need to be here?
2.
What kind of 2?
Negative 2.
Negative 2. And what does my sum need to be?
Negative 1.
Negative 1. Okay? So what's the only multiplication problem that's going to equal 2?
Negative 1 times 2.
Okay, negative 1 times 2 equals negative 2, or,
Negative 2 times 1.
I'm going to put it in the same order, or positive 1 times negative 2 is going to equal negative 2, right? Both of those will equal negative 2. So what's negative 1 plus 2?
That's
It's,
negative 1.
no, it's positive 1, so does this one work? No, so this one doesn't work, but what's 1 plus negative 2? Negative 1, that's the one that works because it equals negative 2 when we multiply, it equals negative 1 when we add. So my factors is x plus 1 because it's a positive 1 and x minus 2 because it's a positive or a negative 2. That would be my factors. And if we double distribute that, it's going to equal what we started with. So that's a way to check yourself. Okay, so far so good.
Back to you.
Yep, I can. Okay. All right. Number 6. What's wrong with number 6?
There's a number in front of the X.
Yeah, but what's wrong with number 6? It's not in the right order. So, Abby Jo, what's the right order?
T plus.
Abby Jo, what's the right order?
T squared plus 6t minus 6t.
How'd you know that 6t was plus 6t?
Because it's not negative.
It's positive. That's right. Okay, so what do we want factors of this time?
Negative 16.
Negative 16. And what do we want the sum to be?
6.
Okay, now listen. The people that are answering are really probably good at their multiplication tables, and I appreciate that. But maybe not everybody's good at multiplication tables. Okay, if you're not good at your multiplication tables, please just start with 1. 1 times what is 16? 16.
Negative 16.
Okay, yeah, I'll change the signs in a minute. Okay, then do 2. 2 times what is 16? 8. And if you don't know, do 16 divided by 2. Does 3 go into 16?
No.
No, if you don't know, do 16 divided by 3. But my point is, be real methodical about it, okay? And then 4 times 4 is 16. Does 5 go into 16? 6, 7, 8.
Yeah, 2.
8 does, but it's already up there. That's how I know I'm finished. That's how I know I have all the multiplication problems. Okay? Now, you're right that I need to make some of these numbers negative, right, in order to get a negative 16. Right? So does anybody have any ideas of what we can do to make a sum of 6 and a negative 16 when we multiply?
Make the negative. Make the 2 negative.
Make the 2 negative. That'll make that negative 16. And then what's negative 2 plus 8? 6. So Zach found it right there. Okay, so you're just going to have to manipulate your signs a little bit. So I apologize that Math Lab uses T's. I wish they would just keep them as X's. But you will have to put the T's in or they'll count it wrong. I can go back and change that. So if that happens to you and it affects you from getting you have a 73 and you need a 75, just show me that one and I'll fix it for you, okay? But try to remember to use whatever letter they use.
I have a question, Tom.
Okay, 15. Okay? All right, now, I know some of you feel like, okay, I know what's going on, but the second half is a little bit harder. It's not too bad, but let me show you what to do on this. So let's go to the back and look at homework number 8. Okay? All right, what do you notice about what's different about this problem? There's an x squared, there's an a, right? There's all our a's so far have been 1. But this one is a 3. Okay, now for today, the good news is we're going to be able to make these 1. Okay, on Thursday we won't be able to on all of them. Okay, now look what it says right here. It says factor out the GCF first. What's GCF? Greatest common factor. Okay, what that means is, and you want to do this even on Thursday, if you see a number that's in front of x squared, you want to try to divide all of those by that number that's in front of x squared. Does 3 go into 27 and 42?
Not 42.
It does go into 42, believe it or not. It's 14 times. Okay? So what we're going to do is divide each one of these by the 3, which is going to be our greatest common factor. Then you won't be able to factor it out. But for today, you will. On Thursday, you won't, and I'll show you how to deal with that on Thursday. Okay? So when we divide by 3... this is x squared plus 9x plus, and 42 divided by 3 is 14. 27 divided by 3 was 9. Okay, now, that 3 that you divided by needs to go out here. Okay, because if I just wrote that down, it doesn't equal what we started with, right? So I have to put the 3 on the outside so that this equals what I started with. Okay, now we're just going to take this and factor like we've been doing. So what do I want my factors to be? 14, and my sum? 9. So anybody know what it is?
7 times 2.
7 times 2. That's 14, and 7 plus 2 is 9. So keep your 3, and then just put your parentheses down. Donovan, say with me. Okay? Keep your 3, keep dropping it down. But then you just factor this part like we've been doing. X plus 7, X plus 2. Yeah, the next one has a greatest common factor of some x's, so I want to show you that too. Okay. Any questions about that one so far? All right, the next one. What do you notice about this one that besides that we have an A of 4? What else?
They're all powered to something.
The exponents are higher, aren't they? Like it doesn't start with a squared, does it? Hey guys, if it's not a squared, it's not a quadratic. So we need it to be, yeah. And all of these are polynomials, but yeah, this is a 5th degree equation, not a 2nd degree equation.
Therefore, it's
Not quadratic. Yeah. Okay, but do they all have some t's though?
Yes.
Okay, so that means not only is our greatest common factor of 4,
14.
but we also have some t's in common. How many t's do you think that they all have in common?
3.
It will be 3. It's the lowest number. Because think about it. This first one has 5, right? The second one, this one, has 4. Zeke and Donovan, move. The second one has 4. And the third one has 3. So how many do they have in common? 3. So if you don't want to draw that out, it's always the lowest one. Okay? Yes. Yeah, we can't count because since all 3 of them don't have another one, you can't count anymore. Okay, so we're going to divide by 4t to the 3rd on this. Okay? So 4 divided by 4 is 1. I don't have to put the 1. But what's t to the 5th divided by t to the 3rd? What do we do to those exponents? Subtract. So it's t squared. 20 divided by 4 is 5. T to the 4th divided by t to the 3rd is t to the 1st. So we'll just put t. 24 divided by 4 is 6. T to the 3rd divided by t to the 3rd is 0. No more t's. So don't put any more t's on that one. What goes out front? 4t to the 3rd.
Isn't the n number 0 though? Because
it's 6t to the 0.
but the constant's always 0.
The exponent is 0. And do you know what anything to a 0 power is? 1. And what's 6 times 1? 6. So that's the reason I don't even put this. I just put the 6. Okay? Alright. Now, is this a quadratic now?
Yes.
Yeah, so now we can factor that. So what do we want factors of? Factors of 6. And the sum has got to be negative 5. Alright? 2 times 3 is positive 6. So what's 2 plus 3? Both of these have to be negative? Yeah. Negative 2 times negative 3 is still positive 6. Negative 2 plus negative 3 is negative 5. So we're going to bring down our 4t to the 3rd. And it's t minus 2, t minus 3. Because negative 2 and negative 3 were our factors. Yes, ma'am.
Our test will be on paper or phone.
Yes. It'll be scanned from bubble in, like the ones you've been doing in Miss Cecil and Mr. Richards. Or you can just hold them in front of the computer.
It's not
Right. It's not on my phone. Yeah. It's a small choice.
Wait,
Okay.
the answer we have to put 14.
Yes. In the answer, you have to put that whole thing.
14.
Okay? In the answer, put the whole thing. All right, last one. And the reason I wanted to show you this one is because there's a negative at the front. And you need to write yourself a note on this one. A can't be negative.
Can't you multiply by positive 1 then make it all?
I'd have to multiply by negative 1 to do that. A can't be negative when you factor. Okay, so write yourself that note so that'll remind you that you can't let A can't be negative, so we've got to figure out a way to get rid of that negative. Okay. You could multiply everything by -1, but we're going to have to divide on this one anyway, aren't we? What do you think our greatest common factor is? What are we going to try as our greatest common factor? We're hoping -16. Because if I divide by a negative, won't that get rid of that negative? Okay. So -16 goes into all of those. So negative divided by negative is +1 and t squared. And I don't have to put the 1 there. 32 divided by -16 is -2. 48 divided by -16 is -3. And then the -16 goes out front. Then we've got our quadratic.
Look at -3.
Factors of -3. Sum is -2. Okay? Anybody got any ideas?
Yep. 1 times -3.
1 times -3 is -3.
Then 1 plus -3.
1 plus -3 is -2. So we've got -16, t plus 1, t minus 3. And that's it. Okay, there are 2 on the math lab, and you'll like these. There are 2 on math lab that you can't factor. So in other words, when you write down multiplication problems that equal that number, they don't add to be the other one. And there's a box that you check that says it's prime. So if you can't find something that multiplies to be this and adds to be that, you just check prime. Just check prime. There's 2 of those.
So instead of unknown number, it's not prime.
Yeah. It just means it can't be factored. Doesn't mean there's no solution. It just means we can't factor it. If you can't factor it, you have to use the quadratic equation. Okay? Which I won't make you do today. All right? Any questions? Okay, so you have 15 problems. They'll be due on Thursday. And then Thursday's assignment won't be due until the following Tuesday because it's a little harder, and I'll give you Friday to work on it also. All right? Mm-hmm.